Hi everyone. In yesterday's class, we have discussed about Ohm's law, and from Ohm's law, we got the relation R is equal to V by I, and this is your resistance. So where this resistance is coming, that we are going to discuss now. Suppose take a conductor. Take this conductor. So number of atoms will be there and so many free electrons will be there, and these free electrons move randomly. Okay, so when you apply potential difference across this conductor, what will happen? This is your positive terminal and this is your negative terminal. So electrons will move from negative terminal to positive terminal, that we have already discussed in last classes. So now the electrons will move from negative terminal to positive terminal. Actually, these electrons will start drifting. Drifting means something, so many obstacles are there, and this electron is trying to get its path while covering from this distance to this distance. Actually, what is happening here, number of atoms are there and so many electrons are also there, free electrons. So suppose electron is coming like this. So on its path, now one atom is there, so it will collide now. So collision will happen. When collision will happen, what will happen? So this movement will slow down. It will slow down little bit. Again the electron will start moving. Suppose in this direction. So if when it will start moving, then another suppose electron is there, then again it will collide. So what is happening? Slowly electron is moving, but so many obstructions. Electron can't move from this terminal to this terminal freely. So many collisions will happen. So because of this collision, the movement will slow down. So the movement will slow down. That's why this drifting word is there. So electron is trying to make its own path, surpassing all the obstacles and reaching at the positive terminals. So the electron will slowly move, and this is called drifting of electrons. So from there we will get the term drift speed. So what is the drift speed? Actually, this is the average speed with which electrons drift in conductor is called drift speed. And these collisions are only obstructing the drifting of electrons. And this obstruction is only resistance. Resist. It is resisting to the current flow. If electron will move smoothly from one end to another end, so current flow will be there. Now it can't move smoothly. So many obstacles it has to surpass. So that's why this obstruction is called resistance. Do you know what is the speed of electron when electrons are moving in a random fashion? Do you know what is the speed? It is really very high. When electrons will move in random motion, it is around 10 to the power 5 meter per second. But what is the drift speed of these electrons? Drift speed is around 10 to the power minus 4 meter per second. See how small it is. How small it is. This drift speed determines the strength of current. This drift speed determines the strength of current. It is not the speed of current. It is not the speed of current. See, electrons are moving so slowly, we have just now observed. So you can ask a question, if electrons are moving so slowly, then when switch is on, power supply is far off from our tube light, from our fan, all the loads. So when switch is on, immediately bulb glows, immediately the fan is moving, rotating. How? Because electrons are moving so slowly. So how this is happening? Why this fast the electricity is? Actually, this speed of the current is equal when your switch is on, immediately bulb goes because of that speed of current. It is not because of the drift speed of the electrons. So that speed of current is equal to the speed of propagation of electromagnetic waves. Speed of propagation of electromagnetic wave. And in vacuum, the light, what is the speed of the light? That is 3 into 10 to the power 8 meter per second. This thing you know. With this speed, this is the speed of the, it is nearly equal to this speed. Electromagnetic wave propagates. So, speed of current is equal to the speed of propagation of electromagnetic waves. So, when it is switched on, immediately bulb goes. When it is switched on, immediately bulb glows. This is the symbol of resistance R. See the obstruction. It is symbolizes the obstruction. Current is not moving, electron is not moving smoothly. So across this, potential difference is there. From one terminal to another terminal, current will flow. This thing we know. And R is equal to V by I, where V is in volt and I is in ampere. So 1 ohm is equal to 1 volt by 1 ampere. So how you define this 1 ohm? The resistance of a conductor is said to be 1 ohm. The resistance of a conductor is said to be 1 ohm if a current of 1 ampere, flows through it when potential difference of 1 volt is applied. Okay? I think it is clear. Now we are going to discuss about the factors that is affecting our resistance. Factors affecting the resistance. What are those? First point is the length of the conductor. It is the length of the conductor. How length of the conductor is affecting your resistance? So length of the conductor, to understand this, take one wire of small length and take another wire of, this is a bigger one now. Here length is more, here length is less. And both the wires are of same material. Suppose this is of copper, this is also copper. Both are having same material, both are having same area of cross section. That means same thickness. Thickness is same in both the wires. Only length differs. So what will happen? When the length increases, when this length increases, so what is happening? That means more number of these atoms and electrons are there, and these free electrons, when it is moving from this terminal to this terminal, so more collision it has to face. So more collision, this electron will collide more while traveling this much of distance to reach at other terminal. So if length is more, then what is happening? Collision is more. And we have observed, if collision is more, that means this movement is slowing down more. So collision more means obstruction is more. Obstruction is more means resistance is more. That means when the length of the conductor increases, your resistance increases. So if length increases, then collision collision also increases. If collision increases, then your resistance is also increases. So that means you can write resistance is directly proportional to L. You can write resistance is directly proportional to L. So this is your first point. Then what is the second factor that is affecting our resistance? The second factor is area of cross section. So first is length of the conductor, second is area of cross section. I am repeating all these points so that while going through this video, it will help you to memorize easily. Okay. So when you just go through the book or notes, it will not be a trouble for you to memorize the things. So second is area cross section. So what is happening now? Take again one conductor like this and take a big conductor. That means area cross section is more. But again, suppose here material, keep the material same, silver and silver. And again, you have to keep the length also same. Then only we can understand the dependence of resistance on area of cross section. Now, see, a length is same for both the conductors, material is also same. So what will happen in this case? This case, see, when the electron is moving, so it has got more free space. It has got more free space to move. If it has got more free space, then what will happen to the collision? Obviously, collision will decrease. So if collision will decrease, then resistance also decreases. So what does it mean? If area of cross section increases, then collision decreases. If collision decreases, then resistance also decreases. So you can write now your resistance is inversely proportional to the area of cross section. So your resistance is inversely proportional to your area of cross section. First factor was length and it is directly proportional. Resistance is directly proportional to the length. So these two parameters we can combine and we can write like this. And we can write like this: R is proportional to L by A. Directly proportional to length, inversely proportional to area of cross section. When there is a proportionality sign, that means there has to one proportionality constant. What is this proportionality constant? That is rho. So we can write R is equal to rho L by A. Very, very important formula for numericals. And so many short questions are also based on this rho, that is called, rho is known as resistivity. It is known as resistivity. Or you can tell this is a specific resistance. Either you can tell resistivity, what is commonly called, and specific resistance. This is rho. Okay. So R is equal to rho L by A. And what is the unit of this rho? How to find out the unit of rho? R is equal to rho L by A. Then from here, rho is equal to cross multiply R into A by L. And you know R is measured in ohm and A is in meter square. Area of cross section is meter square and L length is meter. This meter, this got cancelled. This ohm is there now. So what is the unit of rho? The unit of rho is ohm meter, you can write like this. Again a important question. Unit of rho is equal to rho meter. Okay. Now this resistivity rho, this resistivity rho depends on your nature of the material and temperature. This rho depends on nature of the material and temperature. Nature of material, which material we are using, and second is temperature. Since rho depends on nature of material and temperature, so resistance, these two factors also affect your resistance. So that means your R will change based on nature of material. If you are changing the material, so R will also change. Clear? R will also change. This rho doesn't depend on the shape and size of the conductor. Like how formula, what is the formula of rho? Formula of rho is RA by L. So write like this. So formula of rho is RA by L. So you will be telling area cross section length. So rho depends on the shape, area cross section length. No, it will not depend. So it is resistivity, you can say, is natural resistance of a material. So natural things, it will not change. It will not, if you will bend the pipe, if you will bend that copper wire, or if you will twist the copper wire, whether this resistivity will change? No, it is fixed. So rho depends on this nature of material. So that means R is also dependent on this nature of material. So it will change. Resistance value will change for different wires. Now temperature. What is the role of the temperature in changing your resistance? So if you are increasing the temperature, so what is happening? The atoms will vibrate more. If atoms will vibrate more, then collision also increases. If collision increases, then your resistance also increases. So we have discussed the factors that are affecting the resistance. First one is length of the conductor. If you are increasing the length of the conductor, then your resistance also increases. And second is area cross section. So if you are increasing the area cross section, your resistance is decreasing. So first is length. If length increases, then R increases. Then second, if area cross section increases, then R decreases. Okay. Then what is the third point? It depends on the nature of material. Then what is the fourth point? It depends on temperature. So if temperature increases, then resistance decreases. Hope I am clear with these factors affecting the resistance. Okay. How you define this resistivity? Question comes in exams, in board exam, important 1 marker. Okay. So how you define your resistivity? Take any conductor of length 1 meter and area cross section of 1 meter square. So rho is equal to R A by L. Okay. So rho is equal to R A by L. So when it is 1, it is 1. This is your rho. So when area cross section is 1 and length is also 1, so what will happen? Rho becomes your resistance. So from this you can define your resistivity. And in physics, all the definition like 1 ampere, 1 volt, 1 ohm, all this resistivity, every definition you can define making other parameters as 1, as unity. Okay. So resistance of a material is defined as the resistance which offered by a your conductor having length of 1 meter and the area of cross section of 1 meter square. And area of cross section of 1 meter square. Okay, hope I am clear with all these resistivity and factors affecting resistance. So it is over for today's lecture. In my next lecture, tomorrow I am going to upload again. So in lecture I am going to discuss some numericals based on the resistivity and this resistance, current related small numericals and some conceptual based questions, because this is very important. So I have to cover this much of numericals or questions after this. Then maybe 1 or 2 class or maximum I will try to do in 1 class. So after covering that, I will move to the resistance connected in series and parallel and how to solve all the numericals. I will try to give maximum rules so that it will be very easy for you to solve the circuit problems. You people are okay with today's class. If any doubts, you can put as a comment. Thank you for watching.